Hi, everyone. Good afternoon. Like I just mentioned, if you've just joined, we're going to get started about 3:33, 12:33, depending on where you are, just letting a few more folks get settled. Cheers. Hi, everyone. Good afternoon. My name's Alex. I run the go-to-market team over here at Chalk. Thank you guys so much for joining us today. Giving everyone just about one more minute to settle in, and we'll kick off today's demo. Okay, perfect. All right, guys, welcome to today's demo, real-time fraud detection with domain-based signals. I'm super stoked to have Neil from Verisoul on with us today, as well as our co-founder, Elliot Marks. Verisoul's doing some of the most sophisticated sort of query planning and models that I've seen in a very long time. So as promised, I will be the quietest and least interesting person on this call to facilitate a really great conversation and demo. Neil, Elliot, do you want to introduce yourselves?
Sure thing. I'm Elliot, one of the co-founders here at Chalk, and we've been working with the Verisoul team for, well, I think over a year now, on a bunch of the really cool models that they've been putting together.
Awesome.
Yeah, thanks. I'm Neil, one of the co-founders of Verisoul, and we've been working with Chalk, like Elliot said, for at least over a year and been super impressed with the platform and it's helped us iterate insanely fast. So thanks.
Awesome. So cool. Neil, you just mind shooting over to the agenda slide page, please? This is going to be pretty straightforward. We just did a small meet and greet. We're going to have a few slides, not too many. I promised a no slide session today, just to get a little context on the problems that we're solving, maybe a little bit about some of the new features that they've been working on, and then we're going to dive right into the code. If you have questions during the demo, please use the Q&A function. I will sort of flag it to the team and we can stop. Otherwise, we have about 15 to 20 minutes allocated for live Q&A at the end. All right, over to you,
Sweet.
Neil.
Sweet. Yeah, so today I'm going to spend probably most of the time on two things. The first is how we're leveraging Chalk at Verisoul. And I'm going to do that in the context of a recent customer case study where we were able to detect a large scale free trial abuse going on. And then the second thing is I'll dive into like a live coding demo where you'll actually just see me iterate on how we're able to detect a lot of fake domains that sometimes fraudsters use to actually abuse free trials. Um, so first, a bit about us. Verisoul is fundamentally a fraud prevention company. So we help other companies detect fake accounts and fraud. This could be like a ticketing platform that's trying to prevent, ticket scalpers. It could be like an online dating app trying to prevent fake profiles, a B2B SaaS company trying to protect its free trial. There's maybe two things that differentiate us. The first is just the sheer amount of signals that we're able to pack into a single decision. I actually think it's like the most accurate product in market today. And then the second thing is really around the life cycle of the user. And so we're able to continuously monitor an account. And so there's a lot of types of fraud, but some of the most sophisticated fraud is it starts as real looking accounts. Think of like a verified Twitter account that you've had for 5 years. Maybe you don't need it anymore, and you decide to go out and sell it online. Well, a fraudster just buys that, and now they're kind of like green for life. And so those two things kind of set us apart, and that's primarily what we're focused on. So what does this look like in practice? So we recently worked with a pretty big notable AI code editor. And within like a few short weeks, it was pretty clear what was going on, which was they had a lot of free trial abuse. So they have like a 2 week free trial, and they have a lot of fake accounts coming into that free trial, basically scraping the AIs through that editor and then never converting. And so the fraud tactics they were actually using, some of them were using fake email addresses, fake domains. Um, almost a third of, or over a third of them were using like data center IPs, very clearly virtual machines. And probably like what's most alarming about this case is really just how blunt the fraud was. So it wasn't even like they were trying to like obfuscate who they were. So there's clear examples of one device even having 2,000 free trials going on at a time. So it's pretty crazy. Um, our hunch is that this case specifically is related to the AI race, and actually, probably this was like what we call the Chinese AI regime, I guess, trying to scrape a lot of the frontier models you can get access through a code editor. But more immediately, it cost the company, we think, over $5 million, both in lost revenue from those accounts never converting, but also it's not free to keep that free trial going. And so the cost of that adds up. So yeah. So in terms of how we use Chalk, in practice, we kind of have like this product architecture slide where we have one account score. Underneath that, we have about a dozen modules that all get rolled up into that score. And so you can think of each of these modules as these really deep wells of intelligence. This could be, like for instance, in network, I know off the top of my head, we have over 800 different features in that module alone. And so you can kind of like spend as much time and get as much data as you want and keep digging and digging into these modules. And so pretty quickly you end up with this sort of like maze of different features, signals. And where it gets even more complicated for us is we have a lot of modules that they kind of cut across many modules. So as an example, you can think of like any feature that you see on this slide can be related to velocity. So, for instance, an email might look fine, but an email in the context of a certain time period, like, 1,000 chalk.ai emails coming through in like 30 minutes, that's suspicious. And so you end up with this really, really complicated set of logic and features. And so that's kind of what brought us to Chalk. So again, some of our big issues, the first was we wanted to move really, really fast, partially because the fraud just moves really, really fast. So we found early on, especially when we would integrate with a new customer, we would almost see like a new chapter of fraud. And so we wanted to like, quickly make features, quickly push out new changes, but our infrastructure just didn't handle that. And then the second thing, and this is probably maybe the most important, is we never take our eye off of accuracy and especially false positive control. And so before we push out any change, we like to back test, typically like 2 to 3 months of data and typically on production data as well. So we know that before we push it, there's almost zero risk that we're going to introduce more false positives and we're almost guaranteed to catch more fraud. And then the last thing is, which you'll kind of see this in the demo, but we have some more wacky ideas that involve various signal sources. And so not everything in our system is just a database read with some transformation on top of it. And so when you have some of these wacky ideas, stitching them together becomes a lot of work. And Chalk, was basically natively able to handle everything that we wanted to do. And so that was really impressive to us. So yeah, I'll just maybe end on this slide and then jump into the code. But life before Chalk, this was kind of like the dark days. We, it would usually take weeks to go to production with an idea. We put a lot of things in shadow mode just because we were, a little bit uncertain what it would be like. We didn't have a great way to backfill and test things. And then I think something that's oftentimes overlooked, but if you've worked in a complicated feature platform, you know what I'm talking about, is there's always this issue of figuring out, this feature works, but you always have to figure out kind of like where and when that feature needs to run. And there's actually a lot of like operational overhead in implementing that. And Chalk actually, because they're built on a query engine, like you basically don't have to decide that at all. They decide that for you. And so the only thing you're really deciding is kind of like which file it makes sense for you to put that in. So yeah, that's it. So let me jump into the code.
While Neil spins that up, did anybody have any questions? Just checking one more time. One, Neil, that I just saw, which features move the needle the most in improving your production quality?
Yeah, I mean, it definitely depends on the module we're talking about. I'll tell you for email, and you'll kind of see this in the demo. One of the features that's moved it the most for us is actually you couldn't do it, I would say, more than 6 to 8 months ago. And so that's something that we're just starting to implement now. And I'll go through and demo that, but a lot of it is based on a lot of the new LLMs that have come out. They're extremely good at synthesizing a ton of information and especially multimodal information. So yeah.
Awesome. All right,
So
over to you.
so what I'm going to do is I've got this notebook here, and what I've done is I've actually just preloaded a set of labeled data. So these are real like domains from the wild. It's about 1,000 domains, and I've labeled them with a certain trust level. And so high trust would be something like, I mean, we can just pull this one up. It's something like a legitimate business, probably. It's got a reputable history. So this is like an escape room in Pittsburgh. Um, so, probably not that risky at all. It should be trusted. So that's a high trust domain. Low would be something, probably that it doesn't have much history. It doesn't really load. It's probably a really fresh domain. Um, it could be like even a disposable email provider. So these are like services that people use to commit fraud. And so let me pull up like this one, for instance. So here's like an example of that guerrilla mail, tons of ads. It looks like you can basically just copy and paste this email and use it if you want. And then Medium is kind of like everything else. It's, maybe the domain was used at one point, but it's no longer in use. It's not like very clear basically how to categorize it. So I've gone through and actually labeled all these through various ways. And what I'm going to do is on this call kind of take a crack at building my own features that try to get really accurate to those labels. And so the first thing I'm going to do is I actually know internally in Verisoul that we have a table with some relevant information already. And so Chalk, super easy to do this. You can just make a SQL resolver, basically tell Chalk, hey, like look at this table. I've just moved the data uh, for this demo, but we do have a table that has this Boolean value that basically is like, does the domain have a valid email server? And then secondly, the date the domain was registered. And so I'm just going to tell Chalk, hey, like, when I ask for these features, you can find them basically in this Google Cloud Spanner table. And so in Chalk, I create this class that matches that schema that I've defined in the SQL. And then I can join on that in my overarching domain class. And so what I'm going to do is actually try to like use these features now to come up with my own trust level. And so I've taken a crack at that already. I've just made like a Python resolver here. And it takes in those two features. So first, that Boolean, if there's a valid email server, and second, the date. And I've just kind of like did what I think was sensible, which is if the domain doesn't have a valid email server, let's just mark it as low trust. And then let's move on to the date. And so for the date, I'm just going to say, roughly if you're like less than a month old, you're probably like a fresh domain. And I probably don't want to give you anything medium or high. If you're less than a year old, I'm just going to stick you in medium. And then everything else, I'll say you're high trust. And so I just wrote this in Python. And now when I iterate on this, what I'm going to do is actually just apply this to a branch server in Chalk. Call it webinar. And while that applies, I'll show you exactly how I'm going to test this. So I can just initialize the same Chalk client in my notebook. And I can actually prompt Chalk to run those features that I just wrote. So that would be like my trust level 1, the has MX, the who is registration date on all the domains in my labeled set. So I'm just passing Chalk this group of 1,000 domains. I'm going to tell it, hey, these are the features that I'm really interested in knowing. So give me those back. And so actually, I've already run this just to save some time. So I'll run this again and just pull the data down locally. And what Chalk's going to give me back is a data set kind of like this, where I've got the domains I inputted, the 950, the different database columns for each of those domains, and then finally that Python resolved low, medium, or high. So let's see if this works here. Maybe bring up the dashboard. Okay. Let me just try this without the branch. Okay, but we'll move on for a second. I'll come back to that. So I've gone ahead and just pulled the data, and you can see that I'm going to run some analysis basically on my labels compared to the trust level 1. And so I get back this matrix of the predicted values and the actual values. And long story short, you don't need to be that knowledgeable of data science to know that this is basically like an atrocious feature. It's not that good at all. And in fact, like I'm missing a ton of these domains that I think I should be getting. And so what I'm going to do is, oh, it looks like it maybe just ran. Okay, sweet. So Chalk's actually just pulling this data now for me. But what I'm going to do is I'm actually going to take another idea that I have, which is this kind of is closely mirroring how I would research a domain, is I might take some of these domains and actually just put them right into Google. So for instance, like when you search something like Chalk AI, you get back like a very, I would say, robust set of search results. There's a LinkedIn page for this company. First of all, they have a great website. There's information about their recent raise, et cetera, et cetera. And so my hunch is that if I search maybe like a low trust domain. So here's one that I know about. I might actually find that there's not really like a robust set of results for them other than other domain vendors basically telling me that this is a fake domain, I should watch out. So here's like a vendor that's just straight up saying this is a disposable email domain. And so my next idea is actually to just go back to Chalk and try to create this, try to basically replicate my process in Chalk. And so the way I'm going to do that is capture the SERP, which stands for search engine results page, for that search, and then look for certain keywords in those results. So in my case, I'm going to look for disposable and temporary, and then basically just treat that as like a flag. So Chalk makes this pretty easy as well. I have a Python resolver that uses requests, super easy, and basically just calls this vendor that I know about, serper.dev. And so I've already set this up, put my API key in, and basically I'll get back like a full payload of the search results. Here's actually an example of that for that same domain. So I'll query this API, basically get back this list of search results, and then look for those keywords in this. And so I'm able to write this Python resolver to do that. And then going back here, Chalk has these really easy underscore expressions for just like really simple operations that are more performant basically. And so I've just decided I'm going to write that kind of in the file in line with just an underscore expression. And so let me update my trust level now to take this into account. So the only change I've really made is all the same logic as before, but now I'm also going to pass in this has suspicious keywords feature and basically test to see, okay, if this domain does have suspicious keywords, just automatically return low. And my guess is that this should improve the accuracy, I think. So let's go back to my notebook. So actually, I'll just go ahead and reapply those changes to the branch server. And this time in my offline query, I'm going to give actually all of the features from the last iteration back to Chalk, just so that I have them locally for my reference, but also the new features that I've made. So the SERP results, the has suspicious keywords. And something really nice about Chalk is you can give it this set of like, hey, this is what I want my data frame to be, but let me just save you the time, and I only want you to recompute basically these new features. And so that's why I'm passing in just these three, the new ones that I've made. So again, kind of for the purpose of this webinar, I've just like already done that, I guess. And so I'm just going to rerun this and pull down the data. So this might error actually again. And so pull down the data. We can assume that basically I pull down the data here. I get back this data frame with now kind of the additional three features that I've made and that new trust level. So I run the same analysis this time, and I basically see that it's actually still really bad, but it's better. So I think we went from, what is it, 42? Yeah, so 42% to like 54% accuracy. It's getting there, but still like would never show this to a customer, right? So now what I'm going to do is I basically have like a third idea, which I do think could be kind of like a wacky idea, but it might be the most similar, I think, to my own process, maybe in the AI era. So I showed you that probably I would just like Google for a domain, but if I was really like interested in knowing a ton about a domain, the only thing nowadays that knows more than Google is probably like an LLM. And so I might actually go to like ChatGPT and basically ask it like, give me a history of this domain and try to qualify if I should trust this or not. And so I'm gonna try to implement that basically in Chalk as well. So my idea is pretty much the following. I'm gonna take this domain, get a screenshot of it, and then pass that screenshot and my search results into, in this case, O3, which is from OpenAI, and basically tell it like, give me back like an overarching report, basically make like a research report about this domain. And then I'll take that research report, which I've called that featured domain report, and I'll pass that to another LLM and tell it, okay, given this report, distill this down to the, 1 or 2 sentence summary, and then finally just one word feature that is low, medium, or high of the trust level of that domain. So kind of a wacky idea, uses LLMs, probably takes longer, but let's see what it comes up with in terms of accuracy. So to kind of dig into some of the detail here, Chalk makes this pretty easy. They have a whole library focused around LLM prompting and specifically multimodal, which is pretty amazing. So what I've done here for the report feature is actually just written like a little bit of logic to say that not every domain will have a screenshot if it doesn't resolve, for instance. So if you don't have a screenshot, just ignore the screenshot aspect of this and just put in the search results and the domain. And we're just templating that right into the prompt. But if you do, put in the search results, put in the domain, but also pass in the base64 encoded screenshot and make the report that way. And so this was like super easy to set up. Chalk gives you a bunch of like easy flags, stuff that I would implement on my own, like number of retries, things like that. And so I'm going to actually try to run this feature the same way. I'll apply it to my branch. Let's go back here to my offline notebook. And so this time I'll run the third iteration offline query, which is it contains my first iteration features, my second iteration features, the ones that suck, and now contains this like new, features text and new classifier trust, which maybe I should show this more clearly, but classifier trust is just the parsed uh, domain trust value coming back from the second LLM. So basically, it should give me that one word like low, medium, or high that I'm looking for to compare. So again, I'll run this. Usually I would run this with recompute, just telling it, okay, you've already run these other features. We know they're not good, but I just want them for reference, but also run these new features. And so I'm not going to try to run 1,000 O3 calls in front of you guys, but basically I've run this before. The data should be there, so I'll just pull that down like this. And merge it with my labeled set. And so this might be kind of interesting to look at actually. But here's like the results of that offline query. So I have all my domains, the label, these old features that I first iterated on, first tried. And then I've got this new feature that I just got back from O4 Mini. So you can see that based on my prompt, it basically gave me back like a JSON looking string that has domain trust as one of the fields. So like low, medium, high, things like that. And this is the parsed version of that. So let's see kind of how we did here. So when you run the analysis on this, it's remarkably better, 96% accuracy. And again, I'm kind of giving it a lot of the same features that I was writing my original rules on, but I'm just giving it to O3 and kind of letting it figure out what else it needs. So O3, maybe more specifically, is useful for this just because I know that it has browsing capabilities. And so while I just did like a very simple search for just the name, you can imagine that O3 might be thinking of like, maybe more focused searches, things like, chalk.ai company or, Lucas or like disposable domain or something like that. And so it's actually able to like really synthesize more information and basically just make my prediction accuracy much better. And so, yeah, so that's kind of like a typical iteration cycle for us. And yeah, I'll kind of pause there.
This is super cool to see. I guess one of the fun things too, I think, is how you translate this to production. Would you want to show like one of maybe how like the online queries page and what one of those looks like?
Yeah, for sure. So yeah, so here's actually, so I guess backing up that product architecture slide, you saw kind of some of the modules that sit underneath that account score. This is basically one of those modules as a query plan. It might be hard to see because we just have so many features, but we kind of just, have been working on this a while, kept iterating on it, kept adding more features, taking out some features. And so this actually like is basically one of the modules in production right now. And it's purely running on Chalk. And so that's kind of like what this looks like on steroids is you've got, like I said, those deep wells of information that you can kind of keep doing research into and keep trying things and eventually just like applying them to prod and basically running them in the online query. And so it's definitely remarkable, like thinking before Chalk, how we basically had written this ourselves, like just within a TypeScript service. And now with Chalk, it's way more organized. The auditability is like incredible, and we can version, every little block that you see here. So yeah.
I had a question. They're sort of coming in. You kind of mentioned some of the wacky ideas that, you were coming up with. Were there any sort of wacky ideas, you don't have to give away the secret sauce, that like would never have been possible unless getting introduced to Chalk?
Yeah, I mean, I think there are definitely a lot. I don't know if I'm able to share some of them, but a lot of the things that require a lot of layers. Let me put it that way. Like, you're getting like some really obscure field from like maybe a TCP packet, let's say, just because we're talking about network intelligence. And then you're maybe transforming that, maybe adding that with like another field that you get, and then you might be plotting that on like some distribution that you know for a certain region. And so I think without the organization and the framework of Chalk, that becomes like just operationally too complex to manage. It basically sounds like the kind of thing that every, 2 months, the engineer is going to have to re-figure out, relearn like what they implemented. But with Chalk, it's really kind of like nicely broken out. And what I think is, pretty unique from a data science perspective is each of those intermediate features you can basically reuse them in any other feature. And so that's kind of where a lot of our ideation has come from, is understanding that, oh, we did make this, intermediate score for this other module. Can we just reuse that or reuse that exact logic even in this module? And so basically Chalk makes things very modular and very easy to follow. So that's been great.
Awesome. Um, Question from fellow Chalk customer to fellow Chalk customer. It
Okay.
sounds like somebody is pulling scores into the XGBoost models into Chalk by wrapping the model in a fast API service, and then the Chalk resolver will call it. She's wondering, and follow me here, I speak a little quickly.
Okay.
She's considering simply calling the models from the resolver and skipping the fast API altogether. Is that how you guys are approaching these things, or is advice you might have for
Yeah.
a Chalk customer?
Yeah. I think it obviously depends on the size of the model, but in production today, we're running, I think, like at least three models that I know about that are just a file in our Chalk repo. And so we're actually just running it on the Chalk server, super fast, super lightweight, and gets rid of that added fast API dependency.
Got it. Um, So I've gotten two of these so far. Is it possible to go back into the slide on your thesis around the China AI regime? I think that's like a fairly bleeding edge thesis that you have
Sure.
there. Is there anything maybe
Sure.
worth deep diving on a little bit?
Sure. Yeah. Yeah. So is there a specific question around it or?
It was literally, can we go back to the slide and chat about this a little bit more?
Sure. I mean, I think so in some ways this is definitely like I would say an extreme case, but in a lot of ways it actually isn't. We've helped a bunch of B2B SaaS companies that do have a free trial. We have a public case study right now with Clay, if you've heard of them. They're like a kind of like a marketing AI company. Um, And so these companies that have, basically like I would say an LLM behind some software in a free trial are really, really susceptible to this type of abuse. It's basically like a free way to get access to an LLM. And so, yeah, I would say like what is surprising about this is just how like brute force and kind of like in your face it was. There was not really an effort to like rotate the IPs even or kind of like, which oftentimes you do see with a lot of like sophisticated fraud. But in this case, I don't know for sure, but I think, emails like that Gorilla Mail site that I showed you were just being used. And so it's like, um, which, it's not anyone's fault really. Like they just kind of started looking at this for the first time. But um, yeah, I'm glad we were able to catch it before they lost a lot more money on free trials.
Awesome. Um, if you had to ship one more signal into this pipeline today, what would it be? That's like on interviews where I ask people, what do they want to be
Yeah.
when they grow up?
Yeah, sure. So let's go back. I actually didn't show this in the demo, but one of the things that I'm prompting the AI to do is actually create another feature that I'm calling like domain country, which is basically like um, take your best guess of what's the geography that this domain is most relevant to. So for instance, chalk.ai should probably be like US. It's a US based company, probably most of its customers are in the US. And so I think, and again, this is kind of where our platform just becomes smarter is we're able to do a lot with features across different modules. And so we might have a feature that, and I could implement this that is basically take the domain that you're getting from the email, look at the country of that domain, and then cross-reference that with a lot of the other country signals that are around the network that they're accessing it from, or like, so for example, this would be like, someone with a Chinese IP, but a Verisoul.ai email. Like that, it's not maybe like that, they should be blocked, but that's risky. We only have employees in the US and, a Chinese IP. So it's like, I think that would be kind of where you start to get into a lot more of like catching more of the fraud that people might be missing today.
Gotcha. I'm going to sort of massage a question that I've gotten a few different formats. What are the data sources that you pull in real time? Is it all part of the input? Is it fetched from the databases? What's the secret sauce?
Yeah. So for us, it's primarily going to be from databases. The way our product works is we have a client-side SDK that collects all the data we need for that session's prediction, pretty much. And so we usually tell customers basically you can expect to get an answer within 1 to 2 seconds of when the page loads. And so our SDK like pretty quickly will get like the minimum amount of data we need and then start its continuous monitoring of, behavior, sensors, and there actually is like a lot of data like people might not know, but things like, for instance, when you tap on a phone, there should be like slight gyrations basically of the phone if it's a real phone. Of course, if it's an emulator that someone's controlling through a laptop, like you're not going to get any sort of accelerometer reading. But for most real phones that are, even one that's sitting on a desk or something, like there's going to be some movement of the accelerometer. And so you kind of like stitch a lot of that streaming data with some of the initial like database data that you've, synced in. And then the third thing is really just we have a ton of like outside data sources that we either like clean and collect ourselves or, in some cases even like use a vendor for if we think they're really good. Um, but yeah, that's pretty much the range of sources we'll use.
Awesome. So I know you guys did a lot of DIY work to kind of get this off the ground. What was the migration process like? How long did it take?
That's a good question. I want to say, so we attacked it like module by module, where we just kind of like brought in features from one module into Chalk and then ran that query in the next module. Probably each module probably took like at most a couple weeks to get it all in there. And I think it probably would have been faster even if we had these features written in Python. And so a lot of our features were in TypeScript before, and so we actually went through and like rewrote some of them to be Python or underscore expressions in Chalk.
Got it. Let me just check the Q&A one more time.
Yeah, one of the things I'd call out that's kind of cool about the Python functions is that a lot of them will actually transpile to expressions anyway. So if you write simple Python functions, it's probably just as good as writing an expression for a large class of them, like stuff like this. We'll look at the AST of this Python code and turn it into an expression.
Awesome. Any last thoughts, Neil? Elliot, I'm always happy to give people 15 minutes back in their day. Awesome. Hump day it is. All right. Well, thank you guys so much for joining. We will be sending out the recording if any of your colleagues or teammates weren't able to get it. So look out for a note from Elliot. You can reach out to us at any time. I'm Alexandra at chalk.ai. If you have any go-to-market questions, feel free to reach out to Elliot directly, Elliot at chalk.ai. And Neil, just ping him directly. Shoot him a note, shoot him an email, reach out on LinkedIn. And yeah, Verisoul is awesome. I've worked with these guys a lot. I've had a few conversations. They're doing really, really cool shit in the space. And I'm really thrilled that you guys were able to join us today.
Thanks, guys.
Awesome.
Thank you so much to the Verisoul
Take care,
team
guys.
for putting this
Bye.
together. Bye.